Myself Harshil Parmar, and I am here with my friend Nisarg Mandanka, Yash Patel and Digul Patel, and I am presenting the DMAIC analysis, investigation and control plan for the Boeing airplane case study. Here in this report, we have introduced the DMAIC technique in the Boeing airplane case study. By using this technique, we reduce the defect rate and trigger the manufacturing process. In this report, we will show how we overcome this issue and where we define the source of defect and how we implement the changes. In this case study, we use the root cause and analysis diagram to identify the causes. Further, we use some tools of lean manufacturing like 5S, Kaizen, VSM, which is value stream mapping, TPM, which is total productive maintenance, and we could see the potential benefit of using these tools. 5 stages of the DMAIC section. First one is define, second is measure, third one is analyze, fourth one is improve, and the last one is control. In this define phase, this phase of DMAIC techniques define the potential defect produced during the current manufacturing process of Boeing body casting process. As the first step, project charter was prepared, including all the necessary information such as business case, problem statements, and project goal. To understand the major defect below, table shows the type of defect occurring during one shift, which was one shift which has a production capacity of 600 parts, from which the 570 good parts were produced and the total 75 parts were defective. Here are the type of defect. First one is the proper surface finish. Second one is the improper filling, which is porosity. Third one is holes and threads. Fourth one is burrs and chips, and the fifth one is few other problem. Here is the business case. Company is manufacturing Boeing body by casting process, and they are finding problems of rework and rejection of Boeing body, which directly result in the 15.50% of the productivity. Problem statement. Defect, rejection, and rework of Boeing case constitute the 15% of the production in casting process. And the project goal is to minimize the defect and the rework and improve the current manufacturing process. Second is to implement the lean manufacturing initiatives and to control the defect and reworks and increase the productivity. Third is to provide great customer satisfaction by providing fast supply with high quality as well as more efficient. The objective of the measure phase is to understand and establish the baseline performance of the process. During the conduct of this phase, every process starting from initial to finished product was studied in order to examine the source of defect in the current manufacturing process. Let's understand the process. This process is followed by area AA, where the raw material is loaded into the furnace, which is melted. Then it is transported to area BA, where the sand is prepared according to die, and the melted material is poured in the sand and the mold is prepared. Then it moved further to area CA, where some process is carried out like sewing and grinding to remove the unwanted portion of the part. Then it is placed on the conveyor belt to pass through X-ray test. On the other side, if part fail in the test, it goes for reworking. Then it transferred to the bench grinding for polishing and sharpening the process. After bench grinding, it is removed to the area CA, where it is passed through the heat treatment to strengthen the part. All the parts are transferred to penetrant test, where the hardness of the part is measured. On the other side, rework is done on the failed part. Then after all the parts are sent to sandblast for the cleaning the surface, and final inspection is carried out, and the failed parts are sent for rework, and the old parts are approved and is packed in the standard way, and then it is delivered to the customer. During this study, the efforts were made to overcome the occurring defect during saving process, belt grinding, and the bench grinding process.
Analysis. During the conduct of analysis phase, in order to estimate the source of defect, like proper surface finish, improper filling, that is porosity, holes and threads, burrs and chips, etc., several observations were made in the workplace where this process is carried out. Furthermore, we discussed with the engineering and quality department regarding this process, and we interviewed some production associates in order to understand the root cause of defects. That information was used to draw root cause and effect diagram. So this is the root cause and effect diagram. Hence, from our root cause analysis diagram, we can see that following causes like sewing process, punching press and milling process, dye and mold, grinding, employ and transportation, etc. are directly affecting scraps and reworks. So if we want to understand the potential source of error, we can solve it by taking all the process as x variable, which is directly proportional to variable y, example, scraps and reworks. As we can see that now sewing can create a problem. This is due to unnecessary sewing, which results in dimension changes and creates too much scraps. In the same way, we can summarize from above diagram that how x variable can cause change in y, and likewise we can take out the solution.
During the conduct of implement stage, various implementation were carried on the basis of the results found from the analyze phase. Here we implemented one most important tool of the lean manufacturing, which is Kaizen. Its meaning is to continuous improvement. This phase we put lockouts at various places like control board of various machines such as sewing machines, grinding machine, punching press and milling machines, because any unauthorized person cannot change the calibration, and if any things happen such as unlocking and maintenance, then only authorized person can change the configuration of machine such as to calibration, resetting, etc. From our investigation, we found that employees were changing machine configuration by themselves, which was major cause of defects. Moreover, we created a VSM, value stream mapping, in order to decrease the transportation time and to effectively store inventory as well as to store processing parts. SPC, statistical process control, was introduced in a plant in which inspection is carried out at every point of process, in which a few sample of parts are taken and inspected to ensure that the process is going right, else is to stop, and various steps is taken to maintain the process. Then after we developed specific techniques for heat treatment, like use of inhibited after completion of sintering, like use of specific oil and chemical to prevent from rusting, and train every employees to use inhibitor safely, and we carried out some specific packing techniques to prevent from the break and strain in a product while transporting. One of the most important step was implemented, which was boundary test, and this test is done at the starting and end of every shift, which was mainly for inspection machine like penetration inspection, x-ray inspection, where sample of specification defects parts and standard parts are sent, which ensure that the sensors are working properly, which can decrease the rate of reworks and manual inspection. In the same way, boundary tests were taken in the many machine where sensors are installed to ensure a part is okay. If there is a defect in the part from previous process, it will not allow part to enter in process, and by this we can save manufacturing cost.
Phase of DMAIC, we took some initiatives of lean manufacturing like 5S process at various places where employees are supposed to do 5S process daily in starting at the end of the shift. 5S board is installed in every area where there is all 5S tools like cleaning stuffs. However, by doing TPM regularly of specific time, we can strengthen our manufacturing process, and by regularly upgrading machines and resources as needed, and we can decrease the defect rate of 0.999% and 30% of total manufacturing.
Conclusion. So we can observe from the conclusion that our process is in control and company is saving approximately 1.5 million annually per defects and scraps. Further, the production of Boeing is increased comparatively by 2 to 3 years. If Six Sigma methodology is linked with the business strategy of the industry, then they can achieve more benefit out of such products. Thank you.